So this is take two because I tried this recording before and it failed. Anyway, welcome to the Jet Blast development video blog episode 2. The last episode I showed you like the pre-production of a project. So if you want to make a game, the very first steps, prototype, planning, and stuff. Alright, now you got your prototype done. It's cool. You have planned out your game. You can memorize everything. Like you can play the game in your head because your plan is so good. You know where everything's gonna go. There's no ambiguity. It's not true. There's always ambiguity because things change. So you want your plane to move. So let's say you got a basic movement going on. Nothing too special. Nothing to write home about. You can move left. You can move right. You can move up, you can move down, you can move up and down, diagonal if you want, even. But it doesn't look good. It's floaty, but not in a good way. It's not. It doesn't look like a jet. Like no jet flies like this. So how do we solve this? This is gonna be weird for me because I've constructed it, deconstructed it, and reconstructing it, trying to explain, and it's surprisingly hard because this was one of the first things I did. It's been almost a month now, so it's hard to remember. So anyway, here's the jet stuff, and the movement stuff is basically basically this and this. So I've kind of decided to do something a bit different. For the jet, I kind of have like a kernel system, so I have a loop that goes through everything and then just keeps going through. So in this loop, it updates the jet's location, the jet's rotation. I guess it checks if we're still using a mouse or a joystick, and it updates the jet camera rotation and the turbulence. So most of this is just for the jet's movement. So how does it move? And why is it so complicated? Why do you have like 5 systems just to make the jet move? Well, let me explain. The left and right are pretty much the same, except instead of going left and right, it's up and down. So yeah, I'm just going to explain left and right. Up and down is the same thing, just change the names of the variables to up, down instead of left, right. Alright, first thing we do, oh man, I keep always forgetting to put the timer, so I'm going to put a timer for 8 minutes because I don't want this video to be longer than 10. Alright, so what do we do? I'm sorry for my ADD. So we have our input axis for left and right. We get the direction and we save it because we want to know if we're going left or right. -1 is probably left, and 1 is right, or the opposite. I don't know, it doesn't matter. Also, we need to absolute it and see if it's greater than 0, because to see if like there's any like action on the joystick or whatever. This should actually be like 0.2 or something, so there's a bit of a dead zone. Anyway, if it's not equal to 0, that means like you're actually moving the joystick or whatever, or the keyboard pressing down, then we update the left-right time. The left-right time is actually what we're going to use to control whether the jet's going left or right. So if it's going left-right time is 1, that means it's going full speed to the right. If it's -1, full speed to the left. And then, so how do we do this? We don't want it to like just jump ahead to 1 or 0. We don't want it to be binary. So what we do is that as this is false, we're adding 0.05. Yeah, so if this is 1, it would be 0.05 to the left-right time for every tick of this, and we clamp it down to 1. So we have a linear acceleration. It's not just gonna go poof, zoom. It's just gonna zzz without any easing in between. We'll do the easing later. Alright, let's say you let go, you're no longer doing it. We don't want it to go like snap back to 0 either. We would like it to go woo, 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 woo. So we have to do kind of the opposite here. So we take the left-right time, and we kind of just I have a time step, so it just does it by 0.01. So it would decelerate slower. So it would accelerate fast and then decelerate slower. And then I'm also checking the direction because I need to know if it's left to decelerate to the right, and if it's right to decelerate to the left. And then we add it to the left right time, so it would be a negative number. So if this is 1, we'd be minusing 0.01 from it every time. And we clamp it to 1, and then I have a range here, so instead of it just fidgeting, because like with the floats in Unreal they're not that precise, so I kind of have a range, so I made the time step 1.5 times bigger, and if it falls into that range of the time step, it just sets it to 0, so it doesn't do that. I mean, it's cool for turbulence effect, but for the turbulence we would like to have more control over it and not make it be some random thing. Alright, so this is what controls the jet's left, right, also the acceleration, so that it goes and like that, so it's not it's and the same thing for up and down, but this is not actually setting any position, it's just updating this variable. How does that work? So now we have into the jet location. So this is the function that updates the location. So we're actually updating the scene. So the scene is what controls everything connected to the jet, and then but not the camera. The camera is independent. It's not controlled by this. So we set the location. We go down. We make our vector with our new location. Since the jet is not actually going forward, we only want it to go left, right, up, down. Its x-axis can stay the same, so the x doesn't get touched. And then we clamp it. This is very important. I do a calculation to get the max right, the max right, and max left, and max top and max bottom. That way, if the jet's going and it's like in this range, it doesn't go left, it doesn't go fully off screen, it doesn't go fully right screen. So we clamp it to those values. It's easy. You get your initial location, you get the screen, you do some math. I'll show you really quickly. How do we get a max right, max left? So it's not that. So we get the viewport size. I give myself a bit of buffer. I get the initial location of the jet, and then do some math, some adding this plus this, you get the left max, and then for the right you get this minus this, and then you get, and so on and so forth. It's not that complicated. You can do it at the beginning. Anyway, so we make sure we don't go past these limits. And then so for the y, what we need to do is that we need to add our new value to our old value, so that it's like, ooh, it's moving nicely. And let's look at our let's look at, what do you want to do, left, right, or up and down? Let's do this one. This one should be look left, right. So we're checking if we're going left or right. If we're not, that's what? Why is this like this? Wait, this is for the turning. So yeah, alright. This is just for the looking, because part of the location is based on the looking. I'll show you in the next, so that way the jet is not like pointing that way and moving this way, because that doesn't look right. So if the jet is actually pointing this way, it's actually being kind of pushed this way, and if it's looking that way, it's being pushed that way, because that's like the realistic thing. Anyway, so back to the left, right? So we take the old value, we add it to the new value that we're generating here, and this value, without the looking or anything, just a straight up movement, we got our alpha, so our left right time, which was generated by this dude. It's here, so this is a value between 0, this is a value between -1 and 0. We get our look left right, which is, I'll show you next. It's for the aiming. So that, as I said, jet's pointing this way, it has speed going that way. There's no way that prevent this weird stuff, like the jet can't be pointing that way and going this way. Anyways, so we get our left right time, and we have our max speed, which is 8. It's a global variable, so everything has the same speed. So, and when we ease it in between 0 and 8 or -8, so we have a nice little smooth curve going on, and then we add it to the location. So when this is positive, we're going that way. When it's minus, we're going the other way. Oh, I'm out of time, so I need to hustle with this thing. I guess I should have broken this up into 2 parts. And then I added to the looking direction of the mouse. So the mouse, when it's looking that way, it's only going half the full speed. So if you're looking one direction and you're pushing that, you can actually go 1.5 times faster. So if you're going like this, you're going 8. When you're going like this and you can actually go, I guess 12. And if you're like if you're trying to do this, it kind of like gives you half the speed. So you're kind of like 4. And it's the same thing for the up and down, but it's the opposite. Not the opposite, it's exactly the same, except you just change the variable names and you plug it into the Z instead of the Y, and you update that. Alright, that's cool and all, but what about the rotation, which actually makes it look good? So I'm going to rewire this up so we can see what this does. The rotation, actually, yeah, the rotation comes from the aiming. So we take this thing here. So I have to check for a mouse or a gamepad because the way the joystick works and the mouse works are completely different. So I get the screen resolution. I divide it by the mouse position on the screen, and I do a little bit of math because I'm trying to get this to be between -1 and 1. So that's why I take it, I minus it by 0.5, I multiply it by 2. So, for example, let's say, is this correct? Let's say I had, yeah, I'm hoping, it seems correct. I don't have enough time to go through the math. And then if it's a mouse, then I absolute it, make sure that it's greater than 0. Make sure that it's like actually moving and not in the center. And then if it's true, I just set it to this, the look left right, so it's between 0 and 1. So if it's 1 for the up down, it will look up. If it's -1, it will look all the way down. And that's what controls the look left right. So it's a bunch of values between -1 and 1 that just ease in a bigger value of 8, which is the full speed. So when it's 1, it's full speed on one direction. When it's -1, it's full speed the other direction. It's some two-dimensional math. And then finally, to put all of this together for the rotation, yeah, so with the rotation, we actually have to update the rotation 2 times, 2 ways. I tried to do it with a select thing, but Unreal Engine would always like, so I had to break it up into 2. It would be like, something is wrong, even though it wasn't wrong. It was like, anyway. So the way we do it is like, we have a max angle. I only want the jet to like be able to go 45 degrees, because if it's going if it's like 90 degrees and it's going forward like this, it just looks incredibly stupid. So I try and limit the angle to like 45 degrees. So even if it's going like that, it's kind of passable. But if it was like 90 degrees and going like this, stupid. If it was 180 degrees and going like that, stupid. Anyway, so it's pretty much the same as the other stuff. I take the left right times and I just ease in, from -1 to 1. So 0 means 0. 1, that means it's fully that way. -1, it's fully that way. It's pretty basic. The only complicated thing was the lock on, but that's for another video, I guess. I can show that. So I've rewired everything and it should be smooth. So if you remember earlier on, I'll just do it in 2 goes. I'll show you one final thing to make it extra smooth. I have to compile this. Sorry, it's taking so long. Oh boy, I'm overtime with this video. Come on. Why are you taking so long to compile? Embarrassing. There we go. And let's play. So now we've added the rotation and all that stuff. So there's kind of the thing I was talking about, the fake turbulence. So wow, doesn't that look better? But it still feels something doesn't feel just right. But it, and let's try this the rotation. Ooh. So you see, like I can't. It's even though it's pointing that way, it still looks alright because it is moving in the direction that it's pointing to. I'm not actually touching the keyboard. This is just the mouse speed, and then so the mouse plus the keyboard. So it kind of looks natural. But we can make this a little better. It's just one simple trick. So in the spring arm, if you look at the, well, it's way too fast. Yeah, enjoy my programmer art. I haven't even done one asset yet, so I'm just using primitives. So there's this gold box, and there's the scene. And so the scene is what is actually moves. Then there's a spring arm, and it's attached to the cube, which is the actual uh, jet. So if we do the spring arm, and we enable it, so that means that there should be a lag. Let's see what happens. Should like ease in all the. I have a feeling that spring arm moved. I didn't. So the orange is the gold block is where our jet would have been without the spring arm. So you see it's too instant. There is no easing in. So now we ease in nicely. It's as if we're in an atmosphere. I'm going to make that gold thing invisible so that we can see. Maybe I should just make it hidden in game. That way I don't forget about it. Alright. And then that's how we get our jet mode. Oh my gosh, I hope I explained. I hope this made sense. I mean, if anybody wants like clarification, I will gladly clarify. But this is how this is how I got the jet moving like this. I mean, it feels pretty good. It feels responsive. It moves where you want it. It feels correct. That's the important thing. It needs to feel right. And yeah, I mean, it could use some tweaking for speed and stuff like that, but it's pretty good. Let me know what you think. If you have any questions, comments, feel free to let me know. And yeah, I hope you enjoyed this video. I'm sorry it was weird. It was so hard to explain all of this because the movement system is actually kind of complicated. But yeah, I hope it makes sense. Thank you for watching, and I'll see you next time.